Okay, time for another recap video. This time it's going to talk briefly about the elimination method of solving linear systems. So what we talked about before is the substitution method. Works really well when it's easy or quick to isolate x or y in one of the two equations. So when x or y is already by itself, works great. In all of these examples, you can tell that it might be a little bit more work to isolate for x or y, right? They all have coefficients. If I isolate for x and y, I'm going to have a bunch of fractions. So another method that works better in these situations is called the elimination method. In particular, it works really well when I've already got my x's, my y's, and my constants lined up in this form, or it's quick for me to rearrange it to get in this form. So something x plus or minus something y equals something. I want to make sure I've lined my equation up in columns. So what we're going to do, same thing as before. I've got two equations with two unknowns. I don't know what to do. What I would like is one equation with one unknown. That's what we're good at solving. So I'm going to start the same way. I'm always in this unit. I want to use a blue pen. I'm going to label my equations, equation 1 and equation 2. That never changes. I want to add or subtract these equations to each other. And what that means is I'm going to add or subtract my x's, my y's, and my constants to eliminate or get rid of one of the variables. So for example, here, you notice I have the same coefficient on x in both equations. So if I subtracted equation 2 from equation 1, so let me write that here. If I do equation 1 minus 2, if I do 5x minus 5x, I get 0x, which is nothing. So I've eliminated my x's. Then I can subtract my y's. 3y minus 2y is just y. Then I subtract my constant, 15 minus 5, so y equals 10. So right away, actually, in this case, I've already solved for y. And then again, to solve for x, I can sub y back in, y equals 10, back into either equation. They both look around equally difficult, so why don't I sub y equal 10 into equation 1? So I've got 5x plus 3 times 10 equals 15. So that's 5x plus 30 equals 15. If I move the 30 to the other side, I'm subtracting 30. 15 minus 30 is negative 15. And if I divide both sides by 5, so x equals negative 3. And again, we're always finding a POI. And in this case, our POI is negative 3. X comes first, and then y. So that's the elimination method. I'm going to add or subtract the equations together to eliminate one of the variables. Then I can solve for the other variable, and then the rest is the same. I plug it back into either of the equations to get the other half of my coordinate pair. And again, if we want to verify our solution, we should do a left side, right side check for both equations. I'm not sure if I've given myself really a ton of space here. We'll do our best. So in equation 1, the right side was 15. The left side was 5x plus 3y. I now think, I think x is negative 3. And I think y is 10. So 5 times negative 3 is negative 15. 3 times 10 is 30. Sure enough, negative 15 plus 30 is positive 15. Left side equals right side. Therefore, this point is definitely on line 1. That's good. But remember, for it to be the POI, it needs to be on both lines. So why don't we check equation 2. The left side was 5x plus 2y, and the right side was positive 5. So again, I'm going to sub in x and y into the expression. So 5 times negative 3 plus 2 times 10. So I have negative 15 plus 20. Sure enough, that's positive 5. So I've now verified that this point exists on both lines, so then I did find the solution correctly. That's the elimination method. In this case, it was pretty easy because the coefficients lined up perfectly. It was very quick and easy to eliminate x. Sometimes it's not that simple. So again, I've got my x's, my y's, and my constants lined up. But if I add or subtract my x's and my y's, I can't eliminate them. What I really want is for the coefficients on at least one of the variables to be equal or opposite but equal. So I want the same number in front of x or the same number in front of y. And the way I'm going to do that is by multiplying one of the equations. So really what I'd love here is to have it be a 6, because 6 and negative 6 would add together to make 0. How do I turn that into a 6? Well, I have to multiply this by 2. So to keep the equation balanced, I need to multiply all of equation 1 by 2. So I've got 8x plus 6y equals 22. Now on the bottom, I can just recopy out my second equation. I've got 7x minus 6y equals 8. Now I've got opposite coefficients. So if I add everything together, I'll eliminate the y. So 8x plus 7x is 15x. Positive 6 plus negative 6 is just 0. I've got nothing, so I don't write anything. 22 plus 8 is 30. Now I've got one equation with one variable. I can divide both sides by 15. So I've solved that x is equal to 2. Again, I'm only halfway done. I'm going to sub x equal 2 into either equation. I like equation 1. It's got no negatives. Not a big fan of negatives. So I've got 4 times 2 plus 3y equals 11. So 8 plus 3y equals 11. So 3y equals 11 minus 8, which is 3. So y equals 1. And once I have x and y, I can write my concluding statement that my POI is 2, 1. So sometimes to get the coefficients to line up for elimination, I need to multiply one of the equations by some constant. And when I multiply an equation, I need to multiply all the parts of the equation, my x's, my y's, and my constants. I would say the most common mistake in elimination is students forget to multiply that constant. Let's just do one last example. I've got equation 1 and 2. I might not do the whole question this time. Here, I want to try to get the coefficients to line up. But I can't multiply 2 by anything to make 5. I can't multiply 3 by anything to make 4. So I'm actually going to need to multiply both equations by constants. So what do 2 and 5 both go into? What's their lowest common denominator? Well, we know they both go into 10. So how do I make 2 into 10? I could multiply it by 5, the whole equation. So I've got 10x plus 20y equals 55. And here, well, how do I make that 5x equal to 10? Well, I multiply it by 2. So now I've got 10x. I've got to multiply everything by 2. So I've got negative 6y equals 16. And now I have coefficients that line up. So sometimes I need to multiply both equations by a different constant to get my coefficients to either be equal or opposite. I could have also multiplied the equations by 3 and 4 to have my y's lined up, and then I could have eliminated y. So you're going to get the same answer either way. This time my coefficients are equal, so I need to subtract them. So I need to do 1 minus 2. 10 minus 10 is 0. Here we've got to be really careful with our signs. 20 subtract negative 6 is the same as 20 plus 6, so I've got 26y. And then 55 plus 16 will give me 71. And then if I can reduce the fraction. Sorry, I'm subtracting, so it should be 55 minus 16. I knew something was a bit wacky. Equals 39, because I'm subtracting the x's, the y's, and the constants. And then I can reduce, so y equals 39 over 26. I can reduce that to y equals 3 over 2. Then again, you could plug that back into either equation 1 or 2 to solve for x. And we could go from there. So again, elimination works well when I've got coefficients on both x and y. And when my equation, they're lined up in this form. We just need to be careful about two things. One is, do I need to multiply the equations by some constant so that my coefficients are equal or opposite in either x and y? And my second thing, as I've given you an example here, is be really careful. Do I need to subtract or add the equations to eliminate that chosen variable? Okay, that's all for now. Shoot me an email or comment below if you had any questions, and thank you for watching.